muted if you're not a speaker.
So we are recording right now.
So yeah, Gary, open it up to start with questions. Anyone else have any questions to start with?
Good. Well, thank you all for your support for the NSS. A couple big news items. First one is that a gentleman named John Attaway, who you all may know his son Steve, who passed away recently in New Mexico. John has donated a preserve to the NSS and also a cave preserve to the SCCI. And he's named the one that he donated to the NSS after his daughter Myrna. And then he donated the preserve that he donated to the SCCI. He's named after his son Steve and Nancy, also his daughter-in-law. So very generous donation. I think it's about 17 acres for each donation. And both of the parcels contain some very nice caves. So very fortunate to get those, and just adds to our preserve. So the NSS had a virtual convention. Hope some of you all been able to get online and look at that. It's still up, and you can do everything from look at the photo salon to look at a number of different really outstanding presentations. And then hopefully in summer of next year, we'll be able to all go to Weed, California, when things, I hope, normalize a little bit. If not, I think we'll do another virtual convention. This one was actually quite successful, considering they had a very short period of time when we made the decision in March to basically shut down the actual physical convention and move to a virtual convention. And they did one heck of a job, basically turning 180 degrees and pulling off the convention. There's a lot of really good talks. One of the advantages of having a virtual convention is you're not limited by the length of time for a talk. So you can do a 15-minute talk, you could do an hour talk, and there's a combination of those. So if you get a chance, go on and look at the talks. Also, we were able to record the Luminary series. And so if you're interested in some history of the of a number of really great cavers, Bill Balfour, Bill Jones, and Phil Lucas, they all give about an hour presentation on their caving careers and that. So they've been very popular in the past. So any other questions going on? If not, I'd be happy to start program. I think I can share my screen. Let's see here. I'm gonna do this. That's not gonna work. Well, let me see if I can do this. Let's see, share screen. We're going to do this, share, and then we're going to maybe, that's not good. There we go. Okay. David asked me to do a presentation on a couple different topics. We gave us sort of a selection, but I understand George and some other folks have initiated some tracer testing out in New Mexico. And so Dave thought that that might be a good talk. So thank you. I've been tracer testing since George and I were in graduate school at Western Kentucky University together back in 1980, or a pretty good while ago. So anyway, so if y'all have any questions, please just feel free to jump in. And I will see if I can go from here. Hold on a second. Okay. I'm going to see if I can see you all here. Let me adjust my screen a little bit. Okay. Let's see if that works. Okay. Many of you all are probably had a lot of experience with tracer testing, or certainly with groundwater. And it's always nice to give a talk to cavers versus hydrogeologists, because cavers know a lot more about hydrogeology and karst than most professionally trained hydrogeologists do. That's my experience anyway. Though that's changing. So anyway, let's get right to it. I do have a special thanks. I've been very fortunate to have a lot of really great colleagues and companions and mentors over the years. But in particular, Dr. Calvin Alexander and Nick Crawford, who was my thesis advisor, Derek Davies, Dr. Ralph Ewers, Jim Quinlan, who I was fortunate enough to work with and had a very close relationship for almost 15 years with Jim before he passed away. John Van Berhana and Dr. Steve Worthington, and of course my wife, who's really the one who has put up with me and encouraged me over many years. And I like to also initiate the what I call the standard acknowledgement. This is something that Jim Quinlan taught me. Some of y'all may know Jim, but as he one time stood up in front of a conference when I was introducing him, he said, "Everything I ever hope to be, I owe to Geary Schindel, who made me what I are today." I could have killed him. But anyway, since then we passed it on as some of Jim's legacy. Kind of an interesting little quote, but I've been very fortunate to have worked with some really great people over the years. For those who may not know me, my background is as a geologist, hydrogeologist. I graduated from West Virginia University in 1981 and Western Kentucky University in 1984. And since then I've been employed both as a state government worker, a federal government worker, a state government worker, where I was hired basically to set up the groundwater programs for the state of Kentucky. And then also I've worked in the consulting field where I ran a profit center for a company called ATEC, and then also was a senior hydrogeologist, project manager, karst hydrogeologist at a company called Eckenfelder, which was later bought by Brown and Caldwell. Now I work for the Edwards Aquifer Authority, and I've been there for 21 years. And the reason I'm there is because George Benny told me about the job. And so I thought I'd apply, and they've hired me, and it's been a real interesting position. Very fortunate to have been there. So anyway, there's a couple purposes for the talk. One is to discuss tracers that are used to evaluate, karst aquifers. And the idea is that first you have to identify the tracer or the aquifer type. And we're going to go into probably a little more detail of why we think that's important and how you do it. And so one of the questions is groundwater velocity issues. How quickly is groundwater moving? And if you think that it's moving fast enough, then you can inject the tracer and you may be able to recover that tracer and get a good result. If you are dealing with what some people would call a sand and gravel aquifer, and we'll talk a little bit about nomenclature a little bit better, you may find that groundwater velocities may move 1 foot per day to 1 foot per year. And in that case, you may have to wait a long time to get your tracer. But as some of you all have worked in karst long enough, you'll see that groundwater velocities in karst are much more rapid, commonly on the order of miles per day sometimes. So, you all know what karst is, but there's a lot of different definitions. The one thing that we want to emphasize is that the initial descriptions of karst were really surface features. It was predominantly a geomorphology descriptions of what karst is. But as a hydrogeologist, we're as interested in the subsurface, or more so even. And so when we discuss karst, it's commonly a terrain, including the subsurface, where dissolution, the dissolving of the rock, is the predominant geomorphic agent. And karst can occur on any type of rock, limestone, dolostone, gypsum karst that you have out there. There's even halite, but given a sufficient amount of time, you can actually get karst and sandstone and granite. And so if the rock is moderate to highly soluble, if that type of rock is present, then a karst terrain must form. So so you can look at a karst and sometimes see the landscape and be able to identify certain things that will give you indications. So the first, of course, is moderate to highly soluble rocks, fractures and faults and bedding point parties that have been modified or enlarged through the dissolution process. And then sometimes you'll see dissolution features on the rock outcrop. And you all have worked in gypsum karst where it's much more pronounced than, let's say, some of the limestones. But this picture here is from Montenegro, and those are giant rillen cairns that are over 100 meters long. You'll also see sinkholes or dolines in that, so very common. The other characteristic you'll see is sinking or losing streams. Caves and pits, well-integrated subsurface drainage network, which is a very fancy way to say that water basically flows underground through caves. And then in many cases, you'll also see unique biology within the aquifer, and which is stunning to a lot of hydrogeologists who don't understand or really think that the only thing that's alive in the aquifer is bacteria. Well, until we show them a picture of a blind catfish or a blind salamander or a crayfish in that. And that implies that the biology actually can tell us a lot about the hydrogeology. If you've got blind critters in the cave, then it implies that the conduits are large enough to allow an interaction over a fairly large area. And so the biology can thrive, that there's enough energy inputs for them and things. So as a hydrogeologist, we usually use two terms. The first one is what's called an equivalent porous media aquifer, or an EPM, versus a preferential flow path aquifer. And we're just going to use those terms. Some other hydrogeologists may describe these differently. But an equivalent porous media aquifer is really an ideal sand aquifer. So if you think about sand and gravels that you might see along a river floodplain, that might be what you might call an equivalent porous media aquifer, an idealized aquifer. And they have certain characteristics. They're homogeneous in the sense that the sands, let's say, are well sorted and so you'll see the same type of sand deposits maybe across a large area. They're aerially extensive as in they're big enough that they can actually contain a viable amount of water. They can be characterized as what is called laminar flow conditions, and they can be modeled or described using Darcy's law. And then, of course, the intrinsic permeability, that of the matrix itself, is equal to any secondary permeability. There's no basic permeability differences. And this is going to be important in trying to figure out whether you can actually do a dye trace or not. So if you look at a preferential flow path, or what I would call a karst or fractured aquifer, they are dominated by conduits and fractures. And so they're heterogeneous. That is that you will see huge differences in the makeup of the rock over an aerially extensive terrain. So you might see a very large change in permeability, sometimes over a very short distance. If you think about a cave that you're in and the permeability of water basically flowing through that cave versus flowing through the rock that the cave is in, there can be as many as 11 orders of magnitude difference between the permeabilities of those two units. So they're anisotropic. Again, they're aerially extensive, and they may be described by laminar or turbulent flow conditions. And there are equations, the Darcy-Weisbach equation and the Hazen-Williams equations, which can sometimes be used to calculate groundwater flow in conduit-dominated aquifers. And then the other thing that you all basically you understand this because you've seen it. You've had the rare opportunity to actually go into the aquifer and see the fabric of an aquifer, which most hydrogeologists don't. And that is that the intrinsic or matrix permeability is greater than or different from the secondary or tertiary permeability. And so many of these aquifers are what are called triple porosity and permeability aquifers. That is that the permeability of the matrix is different than the permeability of a fracture, which is different than the permeability of a conduit. And that range, again, can be as much as 11 orders of magnitude and less than a meter of area. So fancy way to talk about karst, but it's important when we're discussing this problem with non-karst hydrogeologists that they understand the difference. And the reason is that the equivalent porous media aquifer is pretty much what most hydrogeologists are taught in school. I know when I took hydrogeology from a person who actually was a karst hydrogeologist, he basically said, we'll discuss that. If you want to know about karst, you can take my other course. But in this course, we're going to talk about equivalent porous media aquifers. And so what you'll see is a lot of people who are classically trained hydrogeologists really have no concept about groundwater flow and karst. So there are a couple other things that we'll see. I'll show you some diagrams here. parallel flow to seepage bases. So if you have a porous media equivalent, you're going to see parallel flow. So you'll commonly see that maybe in, let's say, an outcrop along a river where you have an alluvial aquifer, and you'll see water seeping out along a long linear area. And in addition, there's no down gradient change in permeability. That is, if I was mapping an aquifer over a long area, the permeability that I calculated, let's say near the headwaters of the aquifer, are also the same that I would see down gradient near the discharge point. So there's no scaling effect. Whereas when you're dealing with conduit dominated or karst aquifers, you're going to see a convergent flow to springs. It's like a river network, flows down, water's captured into a watershed, it's funneled into master conduits that then discharge along a river or a stream somewhere. Commonly, the potentiometric surface, which is another fancy way that we describe what's called the water table, is concave rather than convex, if you see in the porous media equivalent aquifer. There are troughs in the potentiometric surface that are caused by conduits. If you have enough monitoring wells, you'll see those. And then down gradient, there's a decrease in head and an increase in permeability. And that makes sense. As you walk usually from a spring upstream, you'll see that the cave or the conduit will get smaller and smaller as you go farther and farther upstream. And dissolution forms a continuous feedback mechanism. And this is one of the reasons why we have caves, is that water basically flows into a fracture, into a conduit, into a bedding plane. It dissolves out the rock, which makes for more room for more water to flow in, which can dissolve out more rock, which can then allow more water to flow in. So you end up with a positive feedback mechanism. And then, of course, there's substantial scaling effects. As I noted, between the rock matrix and the conduit can be vast. And then numerical models are questionable in karst aquifers, and I'll show you some examples of that also. So what's this all shake out to mean? Well, in a porous media equivalent aquifer, an EPM aquifer, groundwater velocity is commonly measured in feet per day to feet per year. Very, very slow. And that's important. If you have a spill of a hazardous material, it may take months or years to basically reach some sort of receptor that you're concerned about. They're generally slow to respond to rainfall. Contaminant transport is relatively predictable with traditional geologic tools such as wells. And then the contaminants are slow to remediate. Once they get caught up in the pore space, they're sometimes very, very difficult to remove. So that's always an issue. Then when you're looking at conduits, karst aquifers, groundwater velocities commonly measured hundreds of thousands of feet per day. Groundwater velocities as much as 3 miles per day are not uncommon. Rapid response to rainfall, don't have to tell you cavers that. Be careful when you go into a cave if there's a chance of rain. Contaminant transport, trying to figure out where a contaminant is going to go and when it's going to come out is very difficult. If you haven't done a lot of research in a particular aquifer in the past, it's pretty dang hard to figure out where something's going to come out and when it's going to come out and at what concentration it may come out. And then well data may not be representative of the conduit. That is, if you think about the conduits, and a good analogy may be a map of the Mississippi River in the United States. And if you threw a dart at the map of the United States, there is a chance that you can hit the Mississippi River on the map, but chances are you won't. And so is that well that you're looking at really representative of the aquifer? The other thing is there's little or no filtration. In the sense that these aquifers don't filter out cavers. They're certainly not going to filter out bacteria or viruses. And so most of the karst and fractured rock aquifers are probably the most vulnerable aquifer type to contamination. And this is where tracer testing comes into play, because tracer testing is an incredibly powerful tool that allows you to ascertain certain information from an aquifer that you normally couldn't do using traditional methods. But if you think about hydrogeology, it really is kind of a remote sensing field. Most people who are working, especially in sand and gravel aquifers, are utilizing water wells, and to remotely sense water level in the well, and to remotely sense water quality. So you would stick a bailer down there, but your ability to actually see the fabric of the aquifer by looking down a 4-inch well is pretty limited. Whereas in karst systems, you can actually go and enter an aquifer and look at that fabric and maybe calculate the width and height of a passage, and measure the scallops and calculate what the flow velocities might be and the discharge might be. So here we're going to get into some diagrams. So on the left, the EPM aquifer, you can see parallel flow lines with a seepage face with a concave water table. And then on the karst aquifer on the right, you'll see that there's equal potential lines form troughs, and can you all see I hope you can see my mouse here. You can see that the conduits that are formed by this basically collect water from the watershed and then discharge it out of the spring. And that's a very simplified version, but that basically shows you the difference between the two. And of course, this is from George Venny's work living on karst. Again, a diorama of karst in action. Okay. And then, of course, also how common is karst. And you can see that you can see New Mexico. It's got a lot of karst, a lot of interesting stuff there. Of course, the Edwards Plateau and Balcones Fault Zone portion. You can see the nice ring in South Dakota, the Black Hills, Wisconsin, Minnesota, Iowa, the Ozarks, all of Florida, the Valley and Ridge on the East Coast, and then Tennessee and Kentucky and Indiana, et cetera. And that the Valley and Ridge extends all the way into New York. So then, of course, there's Alaska and then Hawaii. So let's talk a little bit about karst truce, as we say. If soluble rock is present on the surface and there's a related groundwater system, a preferential flow path aquifer is present, should be treated as one rather than EPM until shown to be otherwise. When I worked for the state of Kentucky, one of my jobs was to provide technical guidance and assistance in some of the bigger hazardous materials spills that we sometimes had. And back in those days, we would have these consultants come in and try and tell us Kentucky rubes how groundwater worked. And they would tell us about sand and gravel aquifers, and we would talk a little bit about karst. And finally, we'd have to take them in and show them a underground stream in a cave and convince them that, you know what, things are just a little bit different in Kentucky and actually in a lot of the world. So sometimes what you have to do is spend a lot of time having folks unlearn many of the concepts that they were taught in school and maybe practiced, and possibly practiced incorrectly. So again, this point is incredibly important when you're designing a monitoring system. So if you're responding to a hazardous material spill, or you're dealing with land use planning issues or groundwater resource issues, and that, it's very, very important to have the right conceptual model for your study. So, and if you don't have the right conceptual model, you can't correctly manage the resource. Remember, if you don't have that understanding of conceptual models in karst, if all you're used to dealing with are sand and gravel aquifers, then you're going to apply the same tools. As we say, you know, when all you have is a hammer, everything becomes a nail, and you don't always make very good choices. And commonly, you get a misunderstanding of the characterization of a contaminant problem. It's not uncommon at all to see people follow US EPA guidance documents saying I need to have 4 monitoring wells at a site, 1 up gradient, 3 down gradient. They put in 3 wells, they never intersect the conduit, and they say, see, there's no problem here, when in reality, the contaminant's moved off site and has impacted a surface water resource or even a groundwater resource such as a well. So we're going to show you a little bit of this. This is a quarry in the Edwards limestone. You can see the nice red Terra Rosa clays that are coming out, very thin soils up top. There are some fractures and conduits and bedding plane partings here, but the rock matrix itself has one permeability. The conduits and fractures will have other different permeability in that. And again, the differences can be remarkable. And so if you were going to install a water well here or a monitoring well, and you were looking at trying to intersect a contaminant that may be flowing through one of these fractures or conduits in that, you may very well not be able to detect it if you don't happen to put your well, get lucky and put your well into one of those features. You may very well not be able to see what you're looking for. Good example, some of these pictures may be ones that George even took a long time ago, I don't know. This is a small creek flowing across the recharge on the Edwards. You see the fractures in the creek bed, and as the water passes across these fractures, it seeps into the ground. Not surprising if you're a caver, that happens. We also see signatures in the groundwater. So this is a graph showing water elevations in blue in a monitoring well that we had. And you can see that as we move across the right, we see a large jump here in the water level of about 3 or 4 feet very, very rapidly because of a 2.24-inch rainstorm event. So the water levels were coming down. We get a big rain, water levels jump, they stabilize. We get some more rain down here on the right, 1.7 inches. You can see the aquifer levels again rise. What's also interesting is you can see the green conductivity line, and that is basically the signature of fresh water entering the aquifer. So the conductivity is stabilized. Then we get a big rain event. You get a little bit of a spike as we think port water is basically being flushed out by a piston effect. And then the water, the concentration of the conductivity of the water decreases. And again, the reason is that rainwater usually doesn't have a high conductivity, hasn't dissolved a lot of the rock or minerals in the rock yet. And then what happens is it'll stabilize after a couple days, and it will start to dissolve out some of the water, and then we'll come back up to equilibrium here. And then again, we see another rain event and the conductivity drops. And so again, this is showing people who don't think that these things are very responsive. This data shows very clearly that you've got incredible response in just some minor rain events of a couple inches. And of course, this is a feature that we have in the Edwards Aquifer, Valdina Farm sinkhole. I think George has been in there a number of times, maybe some other folks too. It's a 150-foot deep vertical shaft. It's a 75-foot shaft down to a ledge, and then those 75 feet, basically the floor of the cave. The Edwards Aquifer Authority cut a trench over to a nearby creek and is using it to recharge the aquifer. So this is the same pit on the right during a big rain event, and the water levels rose and filled that sinkhole, 150-foot high, 150-foot deep pit, filled it in a matter of about 10 minutes while I was out there one day watching it flood. And so it went from no flow at all to basically full in about 10 minutes. So not a good place to be if you're a caver during a rainfall event. Of course, we were talking about biology. This is Texas blind salamanders, a picture from Alan Cobb. And you can see that these things are highly evolved, virtually no eye structure at all. They live deep in the aquifer, fat and happy, until they get sucked out by a well or get blown out of a spring or whatever. What's also interesting is the Texas blind salamander was actually one of the first species listed along with the alligator and the bald eagle under the Endangered Species Act. And is still present in the aquifer and doing pretty well. So let's talk about tracer testing. Now that we understand how aquifers work, we're all experts on it. Talk about a little bit about the goals of tracer testing. So we want to know where the water is going and the flow direction. How long does it take to get there? So how fast? What's the velocity and residence time? And what happens along the way? So there are some aquifer parameters that we can estimate, such as what's called the assimilative capacity of a contaminant. If I spill something in the ground, what concentration is it going to come out at the spring or at a well? So in order to trace, you've got to label your water or mark it or identify it in some specific way so that you can follow it through the aquifer. And there are many different tracers that you can use, and many have been studied, and some of them have been used with varying degrees of success. Okay. So this is a list of tracers. I've used many of them, but not all of them. There are things like flow pulses. I just showed you one in that trace of that well. That is be a flow pulse or a pressure pulse. Okay. You can also use temperature pulses. We up in the Northeast, where the temperatures are commonly higher or lower than the average groundwater, you can sometimes see temperature pulsers. Either rainfall on top of snow will throw a really cold slug of water in, or possibly rainfall on top of a really warm surface may push in the hot water. And if you have a temperature probe, you can actually see some of these in wells or springs. And of course, we've seen sediment coming out of springs too. So sediment can sometimes be a tracer. There have been people who have used floats in caves, everything from barn sweepings to high-tech balls that have all kinds of signal emitting and data collection probes. They're extremely expensive and hard to deploy, but if you can get one to work, you can get some really fantastic data out of them. They're mostly research related. There are also chemical tracers, so you can inject chemicals such as ions, such as, let's say, salt. And there have been a number of traces done where people just backed up a giant truckload of salt, dumped it into a sinkhole or into a stream, and watched for the salt where it might come out. There are non-ionized compounds also, such as organic compounds, gases, and also fluorescent dyes in that. And I've used organic compounds also. They're usually not preferred, but I've worked on a number of places where we've had what are called anthropogenic tracers, and that is for the solvents. There have also been traces that have been done using metals. There's some classic examples of that in the Kentucky area. And there are gases that can be used. Some of us have actually tried those to connect caves together. You can use mercaptan and a number of other gases. Some people even just use dead skunk, find along the road, and throw it in the sinkhole or throw it in an entrance and see if they can smell it at a nearby cave. And of course, there are fluorescent dyes, and that's what we're mostly going to talk about. But there are other tracers that can be used too, isotopic tracers, and they do have their use, and they can tell you a lot about the age of the water. For example, some of the isotopes that can be used to determine how old water is. And they can be confusing and sometimes misled, but the thought is if you're tracing water, for example, you're looking at a spring and you want to know how old the water is going to coming out. And if the water is tritium dead, it's dead to bomb signal tritium in that, then you may suspect that the water is quite old, and your chances of getting a dye trace through there may be somewhat limited. There are also biological tracers. Everything from blood to chicken heads have been used, but there are now attempts by people to look at bacteriophages, that basically viruses that infect bacteria that can be picked up and traced. They're expensive to use, but certainly I guess they have their place. But most people are using fluorescent dyes, and that's what we're going to talk about. So a couple of properties about dyes. Setting up and doing a tracer test can be a lot of work. There's a lot of background work and a lot of field work and a fair amount of lab work that needs to be done. So depending again on what your purposes are for the trace, it may be nothing more than trying to decide whether a passage in a cave that you can't get to the, let's say the sumps out and you want to know if that water comes out in the nearby cave. Well, you might be able to set that trace up and do it fairly easily. If you're looking at trying to define a watershed to look at setting up or designing a hazardous material spill plan, that is much harder and takes a lot more work. So ideally, if you're going to be doing a dye trace, you might as well pick a substance to trace that's easier rather than harder to do. And so if you're going to do that, ideally, you're going to look at these properties in dyes. One is, the first one, of course, is non-toxic. The dye shouldn't be toxic to you or to the ecology or ecosystem that's present. So that means non-carcinogenic, non-teratogenic, non-mutagenic, etc. it shouldn't be present in the system, or if it is, it should be at very low and constant levels. So one of the problems with using dyes is that once you use a dye in a system, you have to monitor it closely if you want to go back in and use the same dye in that system or one nearby. And of course, the material probably is best if it was soluble in water and had the same or relatively same specific gravity. And if you're using for particle tracers, again, neutral buoyancy and low filtration potential. That is, you can trace with, some people have used to trace with lycopodium spores. There are people who use chads. You can use a number of different materials, and you might be able to get them out, but they do need to be neutrally buoyant and fairly small, and then you're going to have to devise a method to capture them. Okay. So, and then the other properties should be easy to detect in very small concentrations. Good fluorescent dyes, for example, have a concentration you can see fairly easily in the 10 to 20 part per trillion range if you have good analytical equipment. It's resistant to absorptive loss and/or chemical, physical, or biological degradation. That is, the dyes don't break down or chemically alter in the substrate. And that's actually a concern if you're dye tracing in areas that have industrial contamination. There are things that will break down your dyes. They're susceptible to quantitative analysis. That is, the easier or cheaper it is to analyze your samples, the better. And then, of course, it's easy to administer, inexpensive, and readily obtainable. That is, that the best tracer in the world you may not be able to afford. So it's important that it be readily available and easy to obtain. So one of the most important properties is that they're non-toxic. Of course, you don't want to be injecting a toxic material into an aquifer. You can get into a lot of trouble, both legally and financially, if you inject something that's a toxic. Okay. And no tracer satisfies all the criteria all the time. What we found is that there are a number of fluorescent dyes that meet most of the criteria and requirements in many situations. Excuse me, my sinuses are acting up. So there are some legal issues that you need to discuss or take care of before you inject dye. And one of those is making sure you have a permit for injection. Some states don't allow you to inject dye. It's considered contamination, and rightly so, in the sense that it is adding something that's not natural to a system. But since most of the fluorescent dyes that we use are non-toxic, and the information obtained from them is pretty important, ideally you can get permission to do an injection. It's also important that you inform your potential receptors, public water supplies, landowners, state environmental agencies, the press, and others, because if your dye daylights and discolors the water and people don't know about it, they could very well call an one of the environmental compliance agencies, which would require them to do an investigation, and they may or may not know that you have been doing a trace. There was actually a graduate student that was fined a considerable amount of money up in Kentucky when they did a trace without informing the state. And then the state went back and actually did their cost recovery for the cost of the investigation. It was many thousands of dollars. So you want to make sure that you've got permission and notifications that have occurred. So, and then sometimes you have domestic wells that you may or may not know about. And this is a well over in the San Marcos area where we injected dye. And the folks did not have a registered well, and it went, I don't know, 1,000 feet or so, and the dye came out in their house, and we got a phone call, and we said, well, we'll come over and see if it's our dye, and looked at it and said, yeah, that's our dye. And we ended up putting a carbon filter system on their well, but it was quite interesting because we injected the dye into a cave that had, I think there was a former bat cave and a lot of guano in the sinkhole or in the cave, and they probably are drinking some pretty biologically active water, is what I would say. So there are two different types of traces. There's what's called qualitative, and then there's a quantitative trace. And so the qualitative trace is one where you want to know is we is or is we ain't positive. And a quantitative trace will tell you, can provide information such as breakthrough curves and concentrations of dye, and you can do a percent recovery of the dye that you get. They're more expensive to set up, but they will provide more data. So let's talk about qualitative tracing. Some of y'all may have done that. And again, that's an absence or presence of dye. Commonly we'll use, the first technique that some people use is what's called the 6-pack and beach umbrella technique. That is, they pour dye in the ground, they sit around with a 6-pack and a beach umbrella, and they watch the spring and see if the dye comes out. And those are usually not very successful. If you know something about the aquifer and you want to, you can sometimes get away with those for demonstration purposes. We have a spring in Texas at Comel Springs that we can do a dye trace to in an hour or two. But generally, people will use receptors to pick up your dye. And so there's two major types. There's what's called granular activated carbon or unbrightened cotton, depending on what type of tracer you're using. If you're using a fluorescent dye, you would use the carbon. If you're using an optical brightener, you would use unbleached cotton. And then what these do is they integrate dye over time. And so they're just sitting there absorbing the dye as the dye goes past. But there's some issues with those. One is you've got to put them in the flow path so that they're not sitting in stagnant water. And the water itself has to be relatively free of organic material so that you don't plug up the activated carbon with other materials that you may not be interested in looking at. For example, if you were tracing an industrial area, you may find that your carbon gets absorbed things like oil or gas or petroleum or PCBs before your dye ever comes past it. So you have to look at the water basically that you need to test the water and look at it before you inject your dye to make sure that you can actually get a good recovery. And then the time resolution is a function of frequency. And that is, the more often you pick up your samples, the better idea you'll have as to how long the dye took to get through. They are cheap to deploy. The analytical costs are maybe a little bit higher than just using straight water. Relatively low tech to high tech, depending again on how you design them. And the charcoal must be eluted. That is, you have to expose the charcoal to a caustic solvent, a solution of basically sodium or potassium or ammonium hydroxide and isopropyl alcohol. And that can be used to elute the sample, and then you can look at it. And sometimes if the carbon is positive for dye, you can see it on there. So there are issues. The charcoal can become inactivated or fouled. It can be difficult to quantify precisely. It can be done visually or with lab instruments. The other problem with it is that people can come by, look at your line that you're holding your charcoal packet or bug in the water with, pick it up thinking it's, oh, a fishing line probably got a catfish on it. They look at it and say, what's this thing? And they throw it up on the bank. And it doesn't do you any good if the thing is sitting on top of, sitting on the bank when you come out to get it. So you can use it though fairly quickly to identify flow paths. Again, it has limited resolution depending on what your frequency of picking up these samples are to determine the time of travel, and limited information on the dye concentrations. They can be cheap to analyze for dye to extract from charcoal, and they provide lower detection limits because they're always there working for you. So the charcoal itself will absorb dye and can actually increase the detection limits by about 40 to about 100%, 100 times, I'm sorry. So they do have the ability to detect concentration of dye at lower limits. So people who do quantitative tracing, which we'll discuss in a minute, commonly also put in charcoal packets as backups for their instrumentation that they're doing. So let's talk about quantitative tracing. And so with a quantitative tracer, you're actually analyzing the water sample. And so when you pull a water sample or grab sample, you're getting a point in time of concentration of the dye. And then, of course, the time resolution is a function of how quickly or how often you pick up a sample. So it can actually be from minutes to commonly days. You can actually develop you can actually create a well-developed breakthrough curve with these. They do usually require laboratory analysis. And there are now instruments that are available that you can do in situ monitoring with. However, the resolution on those are not nearly as good as a benchtop or laboratory instrumentation. And the other problem with them is that if you have a really high sample frequency, and this is true also with quantitative, you can have a huge sample set, and sometimes it gets difficult to manage. It's really important that you have a good method for cataloging and tracking all of your data, because what you'll find sometimes is you'll become awash in data. It's not uncommon to have hundreds, if not thousands, of samples sometimes associated with a good dye trace with a lot of different monitoring points. With the quantitative tracing, you can also identify flow paths, and it does provide some additional data, such as the time of travel and the first arrival and the peak of the dye and the length of occurrence. And those may be important parts of data or information to basically use to model the response of the system in the event that you have a hazardous material spill. So if you had a spill, how long would it take to get there under current hydrologic conditions? How concentrated will it be? And how long will it be there? And it allows you to test a lot of assumptions regarding the aquifer hydraulics and exactly those questions of how long things take to get where they are, what concentration will come out. It does require a significant amount of field time to set up and collect samples, and the sample range can be in the low part per trillion. Not uncommon in really clean water to be able to see a detection rate of 10 to 20 parts per trillion. And if I remember right, parts per trillion, I think 1 part per trillion is equivalent to 1 year, 1 second in 132 years, if I remember right. So very, very low detection limits. And a good laboratory can separate as many as 5 different dyes. And so if you're going to be doing a dye trace, you might as well do, and you're going to do all the field work to set it up, you might as well use more than 1 dye and inject those in different places, because you're still doing the same amount of analysis and the same amount of field work to pick up the data. So here is a comparison of some dyes. You can see these are peaks on the bottom. On the x-axis is wavelength. So this is where we're using a scanning or a luminescence spectrometer. On the left side is intensity, and then you can calibrate that with known concentrations of dye like we're doing here. So you can see these, there are 3 different dyes that are on this, uranane, eosine, and floxine B, which are common dyes that we use. There's a couple other, sulfur rhodamine B, rhodamine WT, and some of the optical brighteners that we can also use. And then when we were sampling a particular spring, we saw this weird unknown substance. We don't know what it is. It probably was a pigment coming out of a paint booth area where they were doing some sign painting, and this is probably a pigment of some sort, but it shouldn't be there, and it probably implies that there was a contaminant that was basically in the system at the time we were out sampling water. Let me come up for a breath here. Tracer testing is actually a really good way to obtain groundwater flow path velocity data. It's relatively inexpensive and relatively high quality data. And again, the data can be used to test all kinds of hydraulic assumptions, and coupled with things like a potentiometric surface map or water table map, hydrophysics, water chemistry can be used to test all kinds of aquifer assumptions. So dye tracing and karst is one of the more powerful tools that we have. There are a handful of people in the US who are doing it very well, who do a lot of it and have good laboratory procedures and that. So it's important, if you're going to have the work done, that you work with somebody who's got experience doing tracing, like George or myself or There's a number of other people, Ralph Ewers, Tom Ailey, number of others. So anyway, tracer testing is, I think, incredibly important. It's actually critical to determine the appropriate response in the event that you have an incident. If you have a spill, it's good to know where that material is already going to go and how long you think it's going to get there. And you can, if you do your dye traces right and actually look at your percent recovery, you can actually predict what concentration of material may come out of your spring and probably be within an order of magnitude, considering there's so many uncertainties with contaminant transport in cars. But that's not too bad. We did this with a big diesel fuel spill that we had in the New Braunfels area, where we lost about 2,000 gallons of diesel fuel. And one of the questions, about 4 miles from Comel Springs, which is an endangered species habitat. And one of the problems, or one of the questions we had was, well, at what concentration will the diesel fuel come out of the spring? And we did some back of the envelope calculations because we didn't have a lot of data. And we predicted that it would come out in the part per billion range. And we were pretty correct. We were pretty much nailed it. And I don't know if we were lucky or good. It's an extremely hard thing to do. But what we did not do is have to mobilize a spill response team to sit around at the spring with absorbent booms for days waiting for the diesel fuel to come out. To set up a good tracer test requires a significant amount of field time to collect and analyze samples. So if you think about it, you've got to go out and identify all your springs and get permission and make sure that the area that you're monitoring is correct for the watershed that you think you're going to be working in. So to set up and design a scientific or regulatory dye trace, there's a number of things that you could do. One is, the first thing is to determine your test objectives. Why are you doing the dye trace? What do you want to learn from it? Are you trying to look at spill response? Are you trying to define a watershed? What are you trying to do? And then we always work under a work plan, which defines what you're going to do, how you're going to do it. And then we identify our sampling locations. So you got to get out, beat the bushes, look at all the springs. And sometimes it's not uncommon to have 20 or 30 sites. And I've worked on sites where we've had as many as 100 different sampling locations. And then you got to figure out your sampling method. Are you going to use carbon? Or are you going to use optical brightener? Are you going to use unbleached cotton? Or are you going to use water sample? Or are you going to use them all? And then you have to determine your sampling frequency. Are you going to be sampling once every 2 weeks? Or are you going to be sampling every 15 minutes? One way to sample every 15 minutes is to set up an automatic water sampler. But as you can see, those are not necessarily simple instruments either. They're also not cheap. They're about $3,000 a piece. And they have to be programmed to remove water. They have maintenance issues, and they also have vandalism issues. So they can provide you some great data, but they are a lot more labor intensive. So the other thing you have to do is look for your background concentrations. Many of the dyes that we use have industrial applications and can therefore be present in the system and that you're trying to use them in. And so you've got to look for background concentrations. For example, uranine or sodium fluorescein, one of the common dyes, one of the most common dyes that you use for dye tracing is actually the material that gives you the green color in the radiator fluid. Many of the other dyes that we use also are used in hydraulic fluid and brake fluid. And so you can get an accidental false positive if you're not careful, if you don't set up your process and your work plan correctly. And then again, simultaneous multi-dye traces are a good idea because it optimizes field and laboratory labor. And then perform your background sampling, and then inject your dyes. And then I'm going to go over a trace as an example that we did. George and I worked on here at the Edwards Aquifer Authority. And so what we were interested in doing is trying to determine the relationship between the Trinity Aquifer and the Edwards Aquifer, and then also trying to determine the role of faults in controlling groundwater movement. So we were trying to test some concepts there, geologic concepts. And then we were interested in groundwater velocities and flow paths, and then it would give us some idea of assessing groundwater vulnerability. So this is the area that we were dye tracing in. This road right here across the top, you see it runs east-west, is 1604, which is the outer loop of San Antonio, on the north side of San Antonio. You can see that there is 281, which is a major transportation corridor that runs basically north-south and crosses the recharge area, the aquifer. So this is the dye tracing, the locations that we did the dye tracing in. You can see there are a number of different wells. Some of them are public water supply wells. Here, there are some monitoring wells, another public water supply well. There are some monitoring wells over in here. And then there are some irrigation wells that are used to water golf courses, some other monitoring wells, et cetera. So we had a pretty good, pretty rich data set here. We had a sufficient number of places to monitor that it was worthwhile to try a test there. So, and there's George. He's injecting dye in a couple locations here. One is Dynamite Cave, the other one's Stone Pond Cave, and we'll show you some of the results there. But we're pouring water in, we're pouring dye in, we pour water in. So one of the things we commonly do is we'll inject, let's say, if we can, about 5,000 gallons of water to lubricate the system in a dry sinkhole. And then we'll pour in the dye, and then we'll pour in another 10 or 20,000 gallons of water if we can, to basically push that dye on into the system. And that you can see the one on the right, George is actually using garden hose to drain a pond into a very small nondescript sinkhole, and he's just pouring the dye right on top of the right there, basically by the garden hose, and that water is suctioning water out of the pond and pushing it into this little karst feature. And that's enough. If you let it run for a couple hours or days, you can actually push a lot of water into the system that way. And here's the results. So I want to show you, this is a geologic map. The Edwards is in blue and red. The red is the upper part of the Edwards limestone, and the blue is the lower part of the limestone that's exposed. I think I've got that right. Anyway, we did about 5 injections out there, and this is the basic results. The dye flowed basically due south. You can see these black lines here. These black lines are faults that have been mapped, and where the colors are different, that's where it's putting 2 geologic formations against each other here. So this is a major fault with about 300 feet of throw, if I remember right. So there are a number of faults. And so one of the, let's see if I can show you a cross section. And so here you go. This will give you an idea. So the Edwards limestone, and then below it's the Glen Rose, and you can see all the data points we injected the dye in, including a couple that actually penetrated the Edwards. Boneyard Pit, Poor Ballard Baculum, and that penetrated the Edwards, and dyes were actually injected into the Glen Rose. So what we were trying to do is determine a couple things. One is the Edwards limestone connected to the Glen Rose and vice versa? So do they transmit water between each other? And then what are the rolled faults in the flow? So here's what we saw with some of our dye tracing results. We saw groundwater velocities as much as 5,000 meters per day, roughly 15,000 feet per day, or about 3 miles per day in locations. And we saw the dye cross a series of faults, and also between the Glen Rose, flow between the Glen Rose and the Edwards limestone. So this is some work that we did with that data. The red lines that you see are derived from a groundwater model, management model that we created. We spent a great deal of time and money trying to develop a groundwater model to help us do management calculations on the Edwards Aquifer. One of the things that we all agreed on is not to use this model for particle tracking. And this is a test basically to show you the results of that. And so the space between the red arrows is 1 year estimated groundwater flow velocity, whereas the blue lines are the dye trace data, which is about 3 to 4 days from the ejection point to the recovery point in the well. Okay, so you can see the groundwater model is way, way off as far as the direction, estimated direction of groundwater flow. It shows groundwater flowing off into the east, and then the amount of time that it took to travel from. So this is basically a 1 year. The space between the arrows is 1 year travel time, whereas the dye basically went due south very quickly. And so here's some of the data. We wanted to look at the vulnerability of the aquifer also. You can see this is from a geologic map that the U.S. Geological Survey had done. They actually put together a vulnerability map of the aquifer. And they, in the areas where we injected some of the dyes here, you can see are not very vulnerable, supposedly. And it came out in these wells right here fairly quickly, within a matter of a couple of days. And so I would tell you that if I had groundwater velocities of a mile per day, I think that's highly vulnerable. And so you have to be very careful about using things like GIS tools to calculate things like vulnerability in karst systems, because you usually cannot. Well, one is the people who are doing the work commonly don't have the experience to be able to understand groundwater flow in karst, and they're applying a lot of assumptions to create some of these maps. So I'm really actually quite opposed to vulnerability mapping in karst. I think it's all vulnerable, and I don't think that you should be splitting hairs as to whether one area in the karst is a little less vulnerable than another area. Okay, and so again, this is some of that data. We've gone from an area that basically is low vulnerability here and to high vulnerability. Yeah. And you notice the other thing is that the dye crossed right across some of these faults. So let's see if we can go to the next trace. I'm going to go back to maps. I'm going to go right back to here. One of the things I want to point out is that when we were first working in this area, the assumption by many of the geologists who had worked in the area in the past had been that the groundwater velocities and the groundwater flow, that these faults would act as big barriers because they're offsetting more than 50% of the aquifer, and that these faults would be a big barrier to groundwater flow, and groundwater flow would flow off to the west and around the end of these faults, about 20 miles off to the west, and then come back underneath the city of San Antonio. And so therefore, development on the north side of San Antonio couldn't impact water quality. Our dye tracing data shows that that's clearly wrong, that these faults do not act as barriers to groundwater flow, that the dyes crossed, this one here crossed 1, 2, 3, 4, 5 faults very quickly in a matter of, again, 2 or 3 days. So it gives you an idea of some of the controls or not controls on the local geology of the site. And it was an eye-opener to a lot of people, and there are other people who argued with us that the data was wrong, that this wasn't actually flowing through the aquifer. And I'm still having discussions and arguments with people who refuse to go in caves and refuse to look at the data. And I'm all about it. We published all this data. I've made the data available to others. Please tell us if you think that we've made a mistake here. But the nice thing about a lot of this dye tracing data is it's empirical. We can go back and reproduce it if we think it's wrong. If we think we've got a false positive or false negative or something, we can go back and reproduce that data and test those hypotheses again. So let me go back over here. All right. So this leads us to one of our issues with management. Most of the dye went very, very rapidly to this well right here, and these diagrams right here are approximations of, basically showing that dye went in point A and it came out at point B here and here. These are large water supply wells or irrigation wells, and we were actually able to suck that dye into these wells after they started pumping, and after a few days after it arrived at this major well right here, 608, which is interesting because this is not a pumping well, it's actually just a monitoring well. And if you'd asked any of us before we did the dye trace, this was not where we thought the dye was going to go. We thought it was probably going to go over this way. But, as we say, the dye doesn't lie. It is what it is. So this dye tracing here gives you a little bit of an understanding of the hydrogeology. And so you can maybe use this to estimate or to formulate a response related to a spill. So this is a sewage spill that occurred in San Antonio. It's about 400,000 gallons of sewage that went on the ground. And the concern is that it could come into some of these large public water supply wells down in this area here. And the problem is we don't know. We haven't done any dye tracing over there. And so one of the questions we had is, where's it going to go? And how quickly is it going to get there? And what wells are we going to possibly impact? And then how do you respond to it? And so we set up a large monitoring network, and we sampled lots and lots of wells, and we never did see the sewage. So again, sometimes these monitoring networks, even in systems that are as porous as the Edwards, may not be adequate to necessarily detect your contamination problems. So anyway, so that leads us to probably the finest dye tracing work that's been done to date in the United States. This is work done by Jim Quinlan and Joe Ray on the what's called the 4-color map, the Mammoth Cave area. So this is about 500 dye traces that were done over about 15 years in time. And for those of you who may not be familiar, this is the Barren River, this is the Green River, this is the Mammoth Cave area. So this is Turnhole Basin, if you've been in that. This is the Hicks or Hidden River System, which is, there was an article in the NSS News this month about the Hicks Cave, which is right over in this area. This is Turnhole and Sandhouse Spring, Hicks, Echo River, Hidden River, Echo River, and some of the other springs, River Stick Springs up here. This is Graham Springs, one of the larger springs in the state, down here at Bowling Green, Kentucky. And so you can see that you can, with enough dye tracing and enough money and time and effort, you can approximate the groundwater flow paths. For example, this is where it's flowing through some caves, and here and here and here. You can actually wade through parts of those caves. But you can see from this dye tracing data, there are not really that many caves that have cave streams in them here that we can actually get into and walk through. So this is where, it may be crossing a sinkhole or a stream or a well. And then you can start drawing groundwater boundaries. And one of the important things is up in this area here is I-65, major transportation route between Nashville and Louisville, and also the L&N Railroad, which transects the area between Louisville and Nashville also. So both of those transportation corridors have had a number of spills. There are also some towns along the way, Horse Cave, Park City, Cave City, etc., that are up on the sinkhole plain that are basically feeding water into these groundwater basins. And there's some fairly notorious contamination problems that have occurred in the area and have been addressed. One of the big success stories, of course, is Hidden River Cave, which is in the city of Horse Cave. And if you all are through Horse Cave, Kentucky, stop in and see the American Cave Conservation Association there and take a tour of Hidden River Cave, which at one time was so polluted that you couldn't even get into couldn't even walk into the sinkhole entrance before you would gag because of raw sewage being dumped into the nearby sinkhole and flowing through the cave stream underneath the city. So, and I'm going to leave you with a couple quotes. This is from Jim Quinlan. He would get up and say this at conferences: "A well-designed, professionally executed dye trace is worth 100 expert opinions and 1,000 computer models." And he said that there are people who argue with him about whether it's really 1,000 expert opinions and 100 computer models. But I think basically he was right. Dye tracing is a powerful tool. And then, of course, the other quote I really like is from Calvin Alexander: "And a successful dye trace changes the way you and your client look at a hydrogeologic system, and it changes it towards reality." So with that, I'd be happy to take any questions if you all are still awake.
My name is Larry, and given the extremely low concentrations of these dyes you can detect, what are the mechanics of avoiding contaminating your samples from yourself?
That's a good question. Good laboratory technique. So if you notice, when George was dumping the dye, he had gloves on, and then George was the only one who actually touched the dye, and the people who were actually doing the recovery of water samples and charcoal packets and that were not involved with the actual dye injection, the concentrations. But yeah, and then of course, good laboratory procedures. You're running, background. You're running sample blanks and spikes and standards and duplicates to test everything from your machine to your process. And then of course also you have to have a really good laboratory control system so that you've got you can collect your data. And then you evaluate your samples to also look. So if you've got a weird anomaly where you've picked up the dye maybe in only one sample, probably trying to tell you that maybe you've got an error in your somewhere in your process. You may have switched samples in the lab and wrote them down wrong. You may have had somebody mark them out in the field wrong, et cetera. Because usually when you detect a sample of dye, you're going to see it in multiple samples at the same location as confirmation. So yeah, there's a lot you can do. And again, depending on whether you're doing science or super science, will depend on the level of effort that you put into it. Yeah.
Thank you.
Yeah.
I have a question that isn't very much hydrological dyeing. On your map, you had like residential streets. So what town is it?
That was San Antonio. I'm sorry. I thought I said that. Yeah.
Well, maybe you did, but I
Yeah.
wasn't paying enough attention. I didn't realize how much that was in town.
Mhm.
Thanks.
Yeah, it's yeah, the northern part of San Antonio is urbanized on top of the recharge zone. And the city's got a lot of stringent controls on trying to protect water quality. We actually have a very large program that's been going on for more than 15 years now, where we're buying conservation easements of property, especially to the north and west, to try and protect water quality in the aquifer. We've protected over 160,000 acres so far with conservation easements. We've spent about $250 million to basically buy land. But you know, northern Bexar County, where San Antonio is growing out on it, it's you know, it's probably a little late to try and acquire property up there. You can only get small parcels. You can barely afford them. So anyway, I hope that answered your question. Yeah. Any other questions? Or George, you have anything you want to add? You've been involved in this stuff for a long time too.
No, great job. You know, to answer Larry's question, the photos of me, we've really upped our technique since then. You know, I did put on gloves. Other people handled the samples. But now, whenever we do a dye trace, when Nickery does dye traces, again, I'll dump the dye because that's just a one-time deal, and then somebody else will go out and collect them. But I'm head to toe covered in Tyvek suit. I change my clothes, you know, afterward, put them in a plastic bag, wash them, bleach them. Bleach will break down the dye. I'll take a UV light and then, you know, scan myself, go, you know, try to find some dark spot in the shade of a tree or in the back of a truck or whatever to see if there's any dye, you know, on me. If there is, I've got some bleach. Most people use a bleach solution. I tend to be rather radical and just wash with straight bleach. Again, to break down that dye, just on the off chance that I might touch something that someone else might touch who's actually analyzing and handling the samples. Or in the worst case, if let's say you, Lewis or Michael, aren't able to go out into the field and I have to go out and collect the samples, I want to make sure I don't cross-contaminate. But yeah, it's we did a lot of work out there, you know, in the Edwards area. I've tried to talk to the city about this. I've shown some of the same diagrams. That one map that Geary showed, that shows the computer modeled flow paths going, you know, going to the east, whereas the dye pretty much goes straight south. I've pointed out to the city saying, okay, here's this area where the geology has been studied in incredible detail. We've got within this roughly 7 square mile area, 7 miles high, 7 miles wide that Geary showed. You've got probably about 100 wells to control your geologic, your hydrologic mapping, and look at how poorly the computer did. Meanwhile, if we look at the Carlsbad area, we've got an area that's modeled about 40 miles by 20 miles. There's 19 wells, very little control. Do we really trust that? I'm not faulting the people who've done the modeling. I just know it's a karst system. It's incredibly complex, and we would benefit here from doing more dye tracing. So But
Oh.
anyway, great job, Gary.
Let me point out bullet point number 2. You know,
Yeah.
maybe some dye tracing would help you all out there. Yeah.
I have a related question. I think George would be more familiar with this, but I recall when Jim Goodbar dumped dyes into drilling fluid and it was detected in wells in the area. I guess the drilling fluid should be theoretically contained in the casing. I just wondered what your thought was on that.
Yeah, what Jim did is they were drilling the wells before, and when they were within the aquifer zone, before they got down to oil and gas producing zones, he dumped some dye. Jim admits that the technique was not optimal. You know, he just had an opportunity to dump the dye and dump the dye and dump the dye in different wells. And so when he got the hits, he can't say which wells went, you know, which the dye in which well went to which spring, because he used uranine in multiple wells. He used eosine in multiple wells. So he didn't have that control. But what he found in summary was that dye that was in wells within the gypsum went to some gypsum springs. Dye that was injected into the limestone went to some limestone springs and to the gypsum, and then some dye that was in gypsum also went into the limestone. So just because we've got the gypsum and the limestone, a lot of people have dealt with them as different hydrologic systems, his is the first indication that there's some crossover that's occurring, and it really needs more detailed study. The results of that were published in the Proceedings of the International Congress in 2009. And if anybody wants a copy of that paper, you know, just let me know. I've got it handy because I've sent it to a number of people who asked for it.
Larry, I did want to bring one thing up that George mentioned. If you're going to be doing dye tracing, it's best to work with a bunch of paranoids because you know, you can do cross contamination, and I've seen some of that in some of the results. So, you know, it can become a real data management nightmare, and that's basically from point of collection to the analysis and even the processing of the data. And so you have to be very organized to make sure that you don't mess any of that up.
I guess what I learned about that is it's fairly easy to pick out that there's a problem.
It's easy to know there's a problem. It's hard to tell sometimes what that problem is. You know, in the sense that yeah, I can tell you we've got a cross contamination issue, but I don't know if it happened in the lab or if it happened in the field. You know, if you don't have really good controls, you know, so yeah, it's, you know, paying attention to detail and being paranoid is a really good skill to have.
Yeah. Gary, I don't know if you remember this, but one of the first traces that we did up in San Marcos, we were injecting multiple dyes, and we got the fluorescein hit, the uranine hit, you know, as we expected. But then from one of the springs that we were monitoring, we get this tiny eosine hit. And we injected eosine, but it was way too soon to see that eosine, and it wasn't showing at the spring where we thought it was. And then talking to some people locally, it turns out that there was a car wreck with brake fluid, transmission fluid, which uses eosine as the coloring agent, not too far. And we were probably, in that case, looking at an eosine hit from that car wreck. We can't prove it, but it was the only thing that really made sense.
Yeah, I've seen that with some dye tracing in Tennessee, where we have a spring that was next to a rest stop, and you know, they went out there to collect the sample one day in the culvert next to the rest stop, and they walk out there, and there's this guy's car just boiling away, radiator fluid wise, running down the ditch, and then right by the packet. You know, who'd have thought?
Wasn't that also detected in Carlsbad Cavern, one reason that they moved the parking lot or closed that one lot?
Yeah, that was a trace that Paul Berger did from the old parking lot, and found that that the dye was seeping down to Devil Spring and several other places down to the cave. moving at a relatively slow rate, which is not surprising for a variety of reasons. For one, being a desert environment, the other being a hypogenic cave, formed from the bottom up, as opposed to formed by water trying to recharge an aquifer. But that's one of the reasons that they moved it.
The other thing is it depends on what you're trying to do with the data. Because I've done dye tracing with cavers where we're trying to figure out whether a particular pass stream and a passage goes to cave A or cave B, and we've injected dye, and on a Sunday before we left, came back 2 weeks later, picked up our packets, and ran them in the campground, with some isopropyl or rubbing alcohol and a little bit of drain cleaner fluid, and got a good positive result, and it's very simple, I'll call it kitchen top science. But then I've also worked on, Superfund sites where we've done dye tracing, and you can just assume you're going to court. And by God, you better make sure you've crossed all the T's and dotted all the I's and follow the work plan and can justify all your data. And that trace cost a little bit more than, and it took years, litigation to sometimes get people to convince that they can, and they will bring in experts, and there's nothing more than, we as tracer tests like to do is try to throw egg on somebody else's face who might have either screwed it up, or to defend them if they've done a good job. I've worked across from Nick and Crawford and Ralph Ewers and a number of other people, Tom Ailey and that, and making sure that folks are honest. Matter of fact, when I was working with the state of Kentucky, it wasn't uncommon for us to have a consultant come in here and like I say, going to show these Kentucky rubes how to do groundwater work, and we finally convinced them that because they've never worked in the karst system, they need to hire somebody, or we're going to have to spend a lot of money teaching them how to do dye tracing, and the client's going to end up basically having to pay for that because we're going to do cost recovery. And so they'll commonly go out and hire a specialist to work, on a large project like Ralph or Nick or Tom or somebody. We've worked with Gareth and that. So it's a small group. Most people who are doing dye tracing basically know each other or know of them, and that people who are doing a lot of it anyway.
Hey, Gary, this is Rod Horrocks. Fascinating presentation. I did have a question. What is the longest dye trace in terms of time that you've seen in Texas?
Oh, God. Certainly weeks. So one question would be, we put 60 pounds of dye or 40 pounds of dye in the ground and never saw it.
40 pounds.
That's 5 or 6 years ago. So it's kind of like, the submarines that haven't come back from, patrol in World War II. Are they still on patrol, or you're not going to see them? And that, so, it's a bad analogy maybe, but, sometimes you'll lose your dye. And if anybody who's done any, if you've done a fair amount of dye tracing, you've lost dye. And the problem with not being able to recover dye is it's hard to say why. Did I not use enough dye? Did I not wait long enough, or did I not monitor enough locations? And it's hard to prove a negative. So you go back and you spend your cost. And the flip side of it is we'll just go in with 1,000 pounds of dye and inject a lot of dye. And the problem with that is you could very well impact the public or private water supply system. And with that kind of concentration, you could do it for years. Most of the dye traces that we do are designed to be non-visible. And that is, you inject the dye, the dyes are detectable as much as 5 orders of magnitude below visibility. So visibility is running roughly a part per million, and we can see 10 parts per trillion with certain dyes and certain waters fairly routinely. And so you try and stay in that range. And there's a classic example of the USGS doing a big dye trace down in Florida where they used like 50 pounds of rhodium WT, and they injected it into a well that was like 500,000 feet, I think, if I remember right, from a very large production well. And they thought it would take, because they used Darcy's law and done some estimates, they thought it would take years to get there. And it took, I don't know, a day and a half, and it turned the water supply red, and it turned a bunch of dry cleaning stuff and the cheese maker and people's clothes and all kinds of problems read. And so far we've been pretty lucky. We haven't hit a big public water supply. We've traced to them. We just haven't discolored them. So, and then you've got the PR, of, okay, well, my God, what have you done to the water? You've turned it red, you turned it green. We're all going to die. What is it? And these dyes that we're using, one of the fluorescein, that green dye is what they put in your eye when you go to the emergency room to see if you've got a scratch in your eye. So these things are pretty, they have the toxicity of table salt. If you ate 20 pounds of it, if you ate 20 pounds of salt, it would probably kill you just because it upset your osmotic balance. So don't do that.
Another question I wondered about, with all these caves and properties and preserves being bought up around the Edwards Aquifer, what kind of effect have you seen that have on the actual aquifer itself?
Well, actually, most of the properties that we're buying are being taken out of development. And so, and they're properties to the west of San Antonio because the properties are cheaper and they're larger. And so we've been buying ranches, in the, anywhere from a couple hundred acres up to, 5,000 acres. And so what we haven't seen an improvement in water quality because most of these are ranch properties. They're not being taken out of production. They're just not being turned into city streets, high density urban development. And so we haven't necessarily seen a improvement in water quality. The flip side is we haven't seen the degradation that we would expect. But I don't know. I'm not sure that we've bought enough property yet to be able to really have a huge impact. We've bought about 5%, 7% of the property that that's included in the entire recharge and conserving zone. And we probably need to be around 25 or 30%.
Question. Oh, sorry.
Yeah, go ahead.
In karst aquifers, like gypsum karst, Burton Flats, for example, outside of Carlsbad, there's mass events where you are going to have an influx of water, but for the most part, a lot of those stay relatively dry, and there is a lot of oil and gas in that area. I work on environmental projects all across the Permian, and so I've done a lot of groundwater sampling in those areas. And I was curious, when you get to the bottom of some of those caves, then they hit the water table and that water is relatively static and it's not moving through. I mean, apparently, when you look at it, it's not moving through much. What is the suggested way of sampling something like that? Like, we use passive samplers on certain water wells in certain places that have approved it, like NFPD, doesn't necessarily, or OCD as well, doesn't necessarily like that as much as, going back to just doing low flow or filling out the classic way. What are some of the techniques for something like an aquifer like that, where you're looking at the water and you're trying to find the best way to figure out whether or not, that water is contaminated and it's not just surface runoff?
I don't know. So, are you using gorge orbers or passive?
Because, I've used passive samplers in Texas before on some sites, on some pretty large sites that are they're basically, you drop them down on a fixed length into the well, and then they'll collect it over time. It's got a little weight on it.
Yeah.
And we know, you're supposed to purge the well out. You're supposed to get you're supposed to get out 3 volumes worth, et cetera, which I've always kind of found that people kind of half-ass that, unfortunately, when they're trying to gather data. Because most of what we're testing out here is BTEX, TPH, chlorides, and TDS. So that cities like what you're doing, have a lot of, probably some of the similar, but a lot of different things you're testing for. But I've been to the bottom of a cave recently that the water just kind of had that foul smell to it. And it was out in the Burton Flats about 3 or 4 months ago. I'm just wondering, because I know they mentioned sampling it before, but would putting a dye trace into something like that even really produce something, since there's not much discharge area that you can really find out there? I mean, there's a ton of caves, but I was just curious.
Yeah, I would. Well, there's 2 questions there, and I'm gonna The first one is we probably have the most extensive data set on using passive samplers that has been done in the US. And of course, we haven't written it up, partially because the data is pretty damn ambiguous. We've been sampling, for multiple years using gorge orbers and a couple of the other passive sampling systems, and at the same time pulling water samples when we pull those samplers and analyzing them for a wide range, spending $1,500 per sample to analyze those things for, for everything under the sun, herbicides, pesticides, PCBs, BTEX, VOCs, SVOCs, metals, the whole works. And to be honest with you, we haven't been able to really discern a lot of trends or anything out of it. I have used gorge orbers to trace contaminant plumes before, using it as a gas indicator, and it's worked pretty well there. But as a passive sampler, in these systems where it's just sitting there at very low concentrations of material, we've kind of actually stopped doing that. We were thinking it would be a good opportunity to look at using them as a sentinel wells, where we would be able to see contaminants that are coming through that aren't being picked up because of, are you familiar with the term aliasing? It's, yes, so basically you understand what it is. We all know what it is. It's just, it's a term that when a signal of higher frequency takes on the characteristics of a signal of lower frequency based on your sampling interval. And that's a fancy way to say, if I told you, Michael, that you need to sample the air temperature in Carlsbad to get me an average air temperature, but you can only do it once a year, and you've got to randomly select that date, how long would it take you to be able to determine, what the average temperature in Carlsbad is? And the answer is hundreds of years, if I only let you sample it once a year or once a quarter, and you had to randomly select those dates. And so in these karst systems where you have materials that may move through in a matter of 3 or 4 or 5 days, if you've got a quarterly monitoring system, you're not going to see it. And so we were thinking actual grab samples in that. We haven't found that to be real useful. Now, in relation to, your problem out there, I'm not familiar enough with the gyp karst to be able to comment on it. That's something probably George or somebody else would be able to do. Other than, I'll tell you, if you think that if you guys end up with 2 or 3 storm events every year that really actually have surface flow and move water, that would be the best time to probably do your dye trace, I think. Or it might dilute out the dye if you get too big a gully washer. I don't know, but
They do have 4 wells that I've seen out there and kind of the heart of some of it. I know that Jim Goodbar had drilled, like I said, at least 4 that I know of. And I'm sure someone else has more information that's been around and familiar with the area. But it is just interesting to see what impacts the oil field does have over time on those systems, especially because there is just so much karst out here.
Yeah.
And a lot of that gypsum karst, unlike the guads, it kind of seems to take a backseat at times, but I have seen, papers on the 128 or along the Pecos. And it is, like I said, it's disheartening because I've seen a lot of stuff in my work travels constantly every day that makes you wonder about it.
Looking at the risks, of oil production and that, and I think that if the surface casings and multiple casings are used, I think you can probably get down through the active karst area. Maybe we certainly have here when we've seen some of them. But the problem is that's just part of the part of the issue. The other part is once you start, so what do you do with the drilling fluids? Well, do you haul them off and get rid of them, or you dump them on the ground? What about the transmission lines, and what about all the other issues? Because there's always leaks and spills and things that get out there too.
Our big issue is produced water.
Yeah, we've had a lot of questions about potential impact to the Edwards Aquifer from drilling in the Eagle Ford Shale here. There are people really concerned about that. And of course, that's about 30 miles, 40 miles south of San Antonio and not in the active karst area. And that we haven't had much impact. But I did go out and look at some of that stuff. And I think the fracking, I think that some of the fracking stuff maybe, I don't want to say it's overblown, but I'm not as concerned about the fracking as I am about the handling of, the product once it's out of the ground. You've got to transport it to market somehow, and that's through leaking pipes and,
Frack water ponds and
black water ponds. Yeah, So yeah,
Yeah.
oil and gas is certainly having an impact on its superficial groundwater sources. As far as the best monitoring system, for setting up the monitor karst, I'm just not familiar enough with the JIP karst out there. I'd have to refer to someone else. Yes. However, for enough money, we can come out there and help you.
I might have thought that before.
Yeah. We can
Thank you
spend
very
a lot of
much.
money. We may not get you an answer.
Well, this was wonderful, Gary. I really appreciate you talking to us. Yeah, Rose, I'm talking right now. Sorry, I have a 5-year-old that I'm juggling as well, too. Did anyone else have any final questions for Gary?
This is Rich Wolford. On a lighter note, you mentioned large quantities of dye, excessive quantities. Are you familiar with the song, the Green Duck song by David Foster?
No, I'm not.
There was on his phonograph record that he issued, I don't know, 30 years ago or whatever, supposedly about a real event where they dumped a huge quantity of dye and it dyed somebody's pond green and dyed the ducks green.
I've dyed raccoons green. I haven't
It's
done
a
any
cute
ducks.
song. It's a humorous song.
Yeah, I'll have to check that out. Yeah. No, I've done a dye trace where we shot about 5,000 gallons of water and then a bunch of dye in it, and then we had a green raccoon come out. He was not happy.
Actually, come to think of it, the NSS Library probably has a copy of that record.
Yeah. Well, it's
But you
probably on
could
YouTube
probably
by
use-
now.
You could probably use that song in some of your presentations.
Yeah, I think that's a good idea. And it's called, what's it called again?
The Green Duck song, it's on a vinyl phonograph record called Nylon Highway, and the song is by David Foster.
Okay. Thank you.
Well, this was an honor, Gary. I really appreciate you being willing to talk to the Grotto. I thoroughly enjoyed it. I'm sure everyone did.
Yeah. Well, you're welcome. I'm pleased to take. I hope you all. And then you guys can spend the next couple meetings having George straighten out all the stuff I told you that was wrong. So,
No, I'm sure it's accurate.
well, it's worth what you paid for it, huh?
Gary would never lie to us very much.
Well, as Jim Clone would say, as he used to be quoted as saying, would a representative of the U.S. government lie to a taxpayer? That was right after Watergate.
It's not safe.
Okay. All right. Well, I'm going to let you all get to your meeting. Thank you all very much. And if y'all have any
you,
questions,
Gary.
Thank you,
yeah,
Thank you, Gary.
well, y'all have a good night. Take care.
Good job.
Thank you. All right. That was wonderful.
If I can figure out how to
Very
get
good.
you out of here.
What's that if you can figure out how to exit?
Yeah.
There should be a
Oh,
hang up button somewhere. You're welcome to stay for the meeting if you want to, but I understand if you want to get going.
are you going to be serving pizza and beer? Not this time.
Unfortunately, not this time.
Okay. Well, maybe I can catch you out there. Is Lucy still open? I can always come out and eat some Mexican food with y'all.
Lucy still is active, yes.
Excellent. All right. Well, I've got to get on to some other NSS business, so I'll let y'all have it. And, I did want to say a shout out to Carol and Dave. How are you all? Good to see you all. And thank you all. You all have a good night.
Thank you. You too,
Thank
Gary.
you.
Thank you. Good night.
Good night.
All right, folks. So our secretary's got to head out by 9, so we have 18 minutes. I think we can get through the meeting in that time, at least through definitely the part that he's sharing on his screen. Is everyone able to see Andy's screen?
I'm going to click the share screen right now. All right, let's see how this
Okey-dokey.
works.
And I can see some of it on my phone, not his screen, but the pictures he should be showing. So got a picture of Gary there at the top. That was awesome. A real
Cool.
treat getting to
Good.
talk to Gary, hear Gary.
Yep.
We'll dive into trip reports. I see a picture for the Guadalupe room there. I know Andy led that trip. Did you want to say anything about that trip, Andy?
Yeah. Led an orientation trip in the Guadalupe room, the Carlsbad Cavern. Got a Gabe in there for his third trip, so he'll be able to get checked off soon, hopefully. So he'll be a trip leader. Also got Brian in from the intern in resources in for his first trip, and got in a person. His name is Sam. He works at the Lincoln National Forest, and that was his first ever wild caving trip ever. It was into that one. So he had a lot of fun first time crawling and putting on elbow pads, knee pads, the whole thing for caving. So it was a really good trip to be able to get someone in there for the very first time wild caving.
You can have some big expectations.
Yeah.
Cool. I saw another trip there for, looks like Ellen led a trip, Leah and Dan for Soapberry Cave Complex. Anyone want to comment on that one? No? Okay.
No.
I saw that she posted a picture and was commenting on that the chamber was, go ahead.
I didn't know if Ellen was going to comment, Dave. So we were out scouting caves for the BLM, and we're going to be doing that tomorrow as well. But so that photo on the right is Leah's hand next to a large pile of scat. And we got up to this cave, one of the entrances for soap, to like what was down there. We went through all the animals that could be inhabiting these caves. Mountain lion, went to porcupine eventually because we did find some quills. But the scat, when it was whole, was about as big as my fist overall. So it was some good sized stuff. We didn't think about javelinas, but it was most likely a javelina living in this cave. The picture on the left is me at a pool, and the goal was to find water enough for 3 liters of sampling for the BLM, and that pool was large enough. So that cave will be sampled for testing, and tomorrow we're going to be doing the same thing, looking for pools of water in the back end of caves. But it was really kind of hairy to go into that cave because we didn't know what was truly living down there. So I went first, throwing rocks around every single corner until we got to the pool.
Nice. Any other trip reports? All right, then we'll move on to upcoming trips. Anyone have any upcoming trips?
What about your trip to Helen's, Dave?
I'm trying to think how long ago that was. Yeah, me and Colin did a trip to Helen's Cave, and we were deploying and collecting radon monitoring devices, the rad track devices. So yeah, all the backcountry rec caves have radon monitoring devices in them. We leave them there for 90 days and retrieve them, then send them off to the lab to be analyzed. Yeah, that was a radon trip to Helen's Cave. Yeah, that was probably about a month ago now, if I remember correctly. And I hadn't been to Helen's Cave since 2012. So it took me a little while to find the interest. Right. I've never been to Corkscrew. That was my first time to Corkscrew. Dan and I and 2 others went up to Corkscrew Cave for a radon monitoring trip. How long ago was that, Dan? A couple weeks now?
It's more than a couple weeks. That was like middle of July.
Okay. Yeah, and I retrieved some radon devices out of the visitor center the other day too. Any other trip reports from anyone?
Well, I had one for
Okay.
Cottonwood.
Cottonwood. Oh, for Mike there. Go ahead.
Yeah. So back about 2 weeks ago, we were in there to pull the stalactites that were down since before my hip surgery, and so then we started using Minori and Todd's new idea of taking photographs of the ends of the broken formations. And a lot of you folks have helped me in the coke table room down there and know how many broken pieces there are. Well, he came up with an idea to line them all up, put numbers on flagging around each one of them, photograph them to scale, and put them on a photographic sheet. So you had maybe a dozen ends colored to the same size to take around, and you could hold that photograph up to the ceiling and look at each stub instead of taking one formation in your hand and looking around at where it goes. And we ended up finding 7 that day of that way. So it's a very effective method. And so we're going to probably put a piece in the NSS News, the conservation issue next year about that and the stalactites. But anyway, we found another piece to that baby Goliath, which is almost 6 feet long now. We found 6 pieces of this formation in a pile, and we still can't find where it goes on the ceiling. And so we're trying to find that out, because I'll install it on the ceiling if we can find where it goes. But it's kind of elusive right now. But that brings to date the total number of formations we repaired there to 124. And we were in there for about 7 hours this time. So the next trip will be next month. So if anybody's interested and want to go in there, I'm looking for up to 3 people probably.
Tuesday
Sounds
or
great.
Wednesday for sure.
Whose idea was that photographic technique?
Todd Roberts and Minori Yoshida. He made this device to hook onto his camera, and it's exactly 1 foot away from their apparatus is 1 foot away from the formation with a scale on it where it's got a ruler. So he takes the picture the same distance from each formation piece. And if you watch that, the presentation I had on the virtual convention, I have a picture of him doing that, and it shows how it's done, and it's very effective. We actually prepared a few formations on that presentation too. So if you haven't seen that presentation and you want to see how he figured that out, go ahead and look at it. But it's very effective. Yeah. I mean, those of you who've been with me to try to take one stub and walk around that delicate area trying to look at the ceiling of where they all came from, you know how hard that is. But if you have a piece of paper that you can hold up and compare 12 different shapes to one stub, it's very effective. And again, if you want to watch that presentation, you'll see how that's done. But I applaud the guy. It's great.
Thanks, Mike.
You're welcome.
Any upcoming trips?
Well, I'm starting one in Fort Stanton next weekend for a cave formation repair and restoration project. So that should be interesting to find out, because I haven't been to the lake room in a long time. So that's where we're going to be working and seeing what that condition's like. But this method I just talked about with Todd is going to turn out to be very useful there, I think, because there's so many broken ones there. But we're going to try using that first.
Yeah, that's awesome.
Thanks.
Moving on to caving news, I want to start with congratulating Mike. Mr. Mike Manser, now a fellow with the NSS. So congratulations. That's wonderful.
Thank you. It is wonderful. What an honor. I'm totally blown away. But thank you very much. Thank you, Dave. Appreciate that.
And speaking of the NSS and acknowledgements, Dan Pollock got an honorable mention in the photo salon. I believe that there's a photo up there on the slide for it. Does anyone else have any caving news? Yeah, Dan's on the call, so good job, Dan.
Yeah, Dan, good. Good job.
Thank you.
Don't put that in the outlet. Any other caving news from anyone?
Yeah, I have something to say. This Saturday, I guess it isn't really caving, but it's caving meeting, another one. The region is going to be meeting on this Zoom program. And I guess George can put out the the key to get into the meeting to the Grotto. But if you're not on the Southwestern Region mailing list, he can get it to you. But it's at 10 o'clock on Saturday morning. It's a Southwestern Region meeting. We've missed our spring and summer meetings, so Scott decided that we needed to have some kind of a meeting. So everybody's welcome to join in on that Zoom meeting.
Good.
Saturday.
Good. Be there.
Okay, good.
Scott ended up getting his own subscription to Zoom.
Oh, did he? Okay.
So he's going to be setting that up, and it won't be going through the Nickery account, so I won't have the information except for what he shares.
Yeah, it's then I don't know how anybody that isn't a member would get the code to get into the meeting, but I guess if you emailed me and I've got it, then I can get it to you. Or George will have it, I think.
Good. Thank you, Carol.
Yeah, thank you. All right, that covers everything for caving news, and we'll move on to the reports. We have 7 minutes till our secretary has to duck out. I think we're doing fine, though. So we'll start with the treasurer report. Or no, let's start with the secretary report, since he has to duck out in 6 minutes.
Okay. Yeah. On our last meeting, we had a Merlin Tuttle give a presentation about bats, and previous meeting we also talked about we had quite a few reflagging trips into Carlsbad Caverns, rope repair, trash pickups, a lot of restoration work out there in Carlsbad Caverns as well as Cottonwood Cave. Caving news was about the NSS convention that took place a few weeks ago, and that was about it. You also had a reminder about joining the Southwest region for a $10 annual membership for the Southwest region.
Good.
All right, thank you. And the treasurer report?
Okay, now can you hear me now?
Yep.
Yeah.
Since we don't meet, we get no dues and we've spent no money. Although I did get a thank you note, so I do know now that the Black Hills Conservation Group received our check.
Okay,
Anyway,
that's good.
So we still have $1,900.
Good.
You know,
All right.
give or take a little.
Yeah. I don't know how I'll get to $5 from our park biologist. Gave me $5 for her to join the Grotto. Valerie Morgan gave that to me today, so maybe I'll mail that to you.
Yeah, I don't know. I just don't come down to Carlsbad enough now since there's nobody, you can't talk to anybody.
Yeah.
Yeah, you're going to be getting an email from Brian, our intern up at the cave park, because he was asking about knowledgeable cavers in the area and trip leaders, and I told him that I didn't think you'd be caving because of COVID, which is smart. Is that accurate?
Yeah, I know there have been some trips in the high quads, but I've not been on them.
Yeah, which is
I wondered if
probably
Mike
wise.
had been. I wondered if Mike had been through the gate.
Yes, they've done a
Mike had
new
been
gate there now. They put a gate on each end of it, but it isn't locked yet. But I understand they're going to be securing it. So they're going to provide probably the combination to select people that they trust. That's what I talked to them about that day. So, but ones that have actually projects going on up there, the work projects, I think is who they would give it to. And if they feel it's been abused, they'll probably put a new combination on that lock. It's like a government lock. It has a pretty fancy brass one. But the two gates are installed. One's at the bottom of 3 Mile Hill and the other one's over by their gate to their house. So that's happened since June 16th when I was in there last. But, you know, that's where it's at. They're going to be securing it at some point.
I always have to comment on this when it comes up. That's completely illegal, and I think we need to deal with it. That's a county road up to their driveway. It's a Forest Service road after that. They're all public roads. They have no right to do that, and they're just doing it, and we're letting them.
Okay, Larry, do you know lawyers that are willing to take us on?
No, I've already gone to the Forest Service and I've gone to the county, and nobody cares very much. I'm not. I think the only solution now is to get media involved, like get a television station to come say, we're going to be here at this time. Okay, you're going to arrest me? Arrest me. I'm on a public road.
And I really don't know what to do, but it is I tried going on Cougar Road. Unfortunately, I chose a time after a rain. I didn't think I'd ever get unstuck. It's scary to go that way.
I haven't been on that road
Really?
a lot, but that big pond, I think, is almost always there.
Wow.
Great.
There's just going to have to be a concentration. They're gradually saying we need to do these things that they have no right to say, and we're accepting it. And something's going to need to be done.
Well, the fact that with COVID, nobody's been caving, it really hasn't been challenged enough. I mean, I haven't been caving since February. As far as I know, Mike goes up there and that's about it. Jennifer went to Three Fingers before the gate went in, but nobody's been up there since. They've been to Virgin, but not to Three Fingers.
Well, caving's not the only reason to go up there. It's highly scenic. I'd like to go up there for photography. It's a hunting area and just a hiking area. It's a beautiful, large part of the quads. It should be open.
Yeah, I've been up there since then, and I talked to the folks, and they say that they like cavers, and if we just communicate with them, it's fine if we're doing caving projects. But I also understand Larry's frustration. And then just a side note, since Andy's docking out right now.
No,
if there's anything else.
still good. I'm still good.
You sure?
Yeah, I'm
right.
still good. Keep going. I'm just gonna talk to Kelsey really fast.
All right. All right. So, any old business that anyone wants to discuss?
Is this new business or old business?
We can start with new business. Yeah. Any new business anyone wants to discuss?
Yeah. This comes from Kelsey. She works at Lincoln National Forest, and they're doing a special event on October 3rd. It's called the Clean Up the Quads, where they're doing a road cleanup from along the Forest Service roads up there, starting from Queen. And so that'll take place on October 3rd of this year from 8 until 5 p.m. So just food will be provided, trash bags and PPE, everything will be provided. I'll give some more information on our next meeting, but that's just if people are free and looking to do some cleanups along the roads out there in the forest on October 3rd.
Okay, good.
Thank you, Andy and Kelsey.
Yeah.
Are they going to send anything out on that? Andy, are the Forest Service going to send anything out officially to the grottos or anything looking for help?
I think it's posted up on their social media and also on their website, but I don't think they're, or hang on. Kelsey?
Yes?
We have a question for you.
Answer, hopefully, oh gosh.
Are you guys going to be like posting stuff about the Clean Up the Quads to like the local grottos or to like different social media pages or things of that nature?
So there's a Facebook page that was created by Eddie County. So that's kind of where it is now, just like a Facebook page. But the forest homepage, it's on their e-fence too. But I can post it. Hold on, we have a visitor.
Yeah, it'll be up on their social media pages.
Okay, well, I'll announce it at the next Sandy Grotto meeting then, next week. So that way everybody's aware. Okay.
Yeah, we'd appreciate it. Great. Yeah, yeah. So it'll be on October 3rd for the date for you, Mike.
8 to 5, you said?
Yeah, it'll be from 8 a.m. until 5 p.m. Or just whenever people can show up from. All the PP, trash bags, those things will all be provided, as well as food for the event as well.
Okay, they're going to be expecting to wear face protection, right, and everything else?
I'm assuming so, yes. And of course, it's all subject to what's happening with COVID. You know, things shut down.
Okay.
Or not. But yeah. So face mask required or different.
So you don't have to have them, but we are going to provide them. And then,
Oh, you're going to provide them?
Yeah.
Okay.
Yeah. And the cool thing about this trash pickup is we'll be able to definitely like spread out. So even if there is a lot of the people, the forest is a big area, and so really the only time that there'll be kind of like a big congregation of people is at like 8 a.m. when everybody's like signed up.
Good.
And then after that, kind of everybody goes off on their own.
And they meet at the Queen admin site. Is that what you said?
Yes.
Mm-hmm. Yep, at the admin building, 3366 Queens Highway.
Okay. Thank you.
You're welcome.
Thanks, Kelsey.
You're welcome.
That's my news.
Any other new business?
No.
All right. Any old business anyone wants to address?
I guess not.
We had, I think next month we're supposed to be doing the Grotto auction. Is that it?
There's no way that can
That's
work.
what we've done every year. We've always done it in September every year, but nothing had been decided upon for this coming September because I wasn't sure how we were going to do it. If anyone wants to throw some ideas out over the next few weeks until then, feel free. We could send out emails and make decisions that way. If someone had an idea
Dave,
right now.
Well, Dave, we have ours. The Sandia Grotto normally has theirs in April, and so one of the ideas I proposed for this is that one person gather all the things that are donated for the auction, and that person they send pictures out to the whole grotto and of what the items will be, and then that way the person on the Zoom running the Zoom meeting can take the bids, and it would work that way. That's what I was planning on doing, maybe October, November.
That's a neat idea.
No, it isn't.
I do like it.
No, the fun of it is the challenge of being, the interaction. Doing it online is like blah. It's like a silent auction where who cares? I mean, you got to really want the stuff. How much of the stuff that's for sale do you really want?
Yeah, well, I think maybe it's the only way to do it, though.
I want all of it, Phyllis.
Who knows?
I just want all of it.
Did we want to vote on this, or did we want to mull it over and people present ideas over the next week or so?
Maybe we could mull it over and maybe postpone it to, if we do decide to do it, maybe do it in October. So kind of mull it over this one, vote on it in September, and then if we do it, do it in October.
Yeah, maybe it could be an outside event.
Yeah.
Do it in somebody's backyard.
Well, the only problem with that is that we've got to deal with the gathering, the social gatherings. What the number limit is 10, unless that's lifted by then.
Yeah. Just an idea.
All right.
Yeah, I know,
so let's. So based on Andy's suggestion about if we were to do it in October, is there anyone that's opposed to, let's definitely not do it in September, and then we'll reapproach this in September for October, so we have the next month for people to come up with ideas and propose it. Does that sound good to everyone? I can't see if for voting. Is there anyone that opposes that idea?
Nope.
All right, so we'll mull it over and discuss the auction in the September meeting.
Okay.
Any other old business to address? I think we covered new business and old business. All right. Well, then I will thank you all for coming. This was a wonderful meeting. Mr. Schindel, always a pleasure. Any final notes before we close out?
Guess not.
No.
All right. Well, thank you all for attending.
Thank
Talk
you
to
too.
next month. Great.
Okay,
Thank you.
thank you. We'll talk to you then. Okay, bye-bye.
Okay.
Have a good night.